Hello and welcome to Mr. Linford's math course. In today's discussion, we're going to be looking at the algebra of complex numbers, in particular, performing the operations of addition, subtraction, and multiplication on complex numbers. And more specifically, we're also going to be looking at patterns of the complex unit I as it's raised to various powers. So the first thing that we want to do is understand how to perform addition and subtraction on complex numbers. Here are two complex numbers. 3 plus 4i is one number. 5 plus 2i is the second number. We have to go and add these two things together. Well, very similar to when you would add things like 3 plus 4x and you would add 5 plus 2x, we would combine the like terms. Similar in this situation, we're going to add the like components together. Remember, 3 and 5 are in fact the real components. So let's add those together. 3 and 5 make 8. Plus, we have 4i and 2i. These are the complex components. So let's add those together. If you have 4 i's and you add 2 more, you get 6i. That is our answer. It's as simple as that. Just like combining like terms, we're going to combine the like components. You add the real components, and then you add the complex components. So let's come up with a little quick procedure. The first thing that we want to do is we can say add the real, remember that's a symbol for real number, add the real components. Step 2, we are going to add the complex components. And I might say for step 3, the final process, write your answer as a complex number. And by that I mean make sure that your answer is in the form of a complex number. So we have 8 plus 6i. That's a complex number form. Try to avoid this. The reason is this really doesn't fit the form of a complex number, and to me, this indicates that you are trying to do 0 plus 6i plus 8 plus 0i. Okay? Now, they would give you the same thing, but it's very difficult to read, especially when we have to go and we have to add or subtract a bunch of these. We want to make sure that we know what are the individual complex numbers. Now, when it comes to subtraction, we're going to do the exact same process. Okay? Subtraction works just like addition. In fact, we can go ahead and we can distribute this negative through. So we could write this as 5 plus 2i plus a negative 3 minus 4i. Again, these are two numbers. 5 plus 2i is a number, and 3 plus 4i is a number. So let's go ahead and subtract them. 5 minus 3 is 2. And then 2i and negative 4i makes negative 2i. And this is our final answer. Again, it's just like combining like terms. Here we're just combining the like components. So if I had to come up with a procedure for this, I would pretty much say to do the exact same thing, except first, distribute the negative. And then I would say for step 2, add the complex numbers like before. And just keep it simple as that. So really, when it comes to addition and subtraction, it's a very straightforward and easy process. Now let's try multiplication. Again, we have two components, two different numbers here, and each number have different components to it. We have one number and we have another number. Now, when we go and multiply these things together, we are going to treat this just like we did with polynomials. You can think of this problem as being very similar to 2 plus 3x times 5 plus 3x. Okay? And in fact, when we multiply complex numbers, we're actually going to use distribution for this, or we could use the box method. So I'm going to go ahead and use the box method. I'm going to take 2 and 3i, and then 5 and 3i. And let's go through and perform this multiplication. 5 times 2 is 10. 2 and 3i is 6i. 5 and 3i is 15i. 3 and 3 makes 9. And I times I is I squared. Now let's go through and let's try to write our answer. Okay? We notice that we have like terms on the diagonal. So we can go and write our answer as 10 plus 15i and 6i is 21i. And then, oh, we have 9i squared. Well, this is not in the form of a complex number. We've never dealt with something where we have an I squared before. We just combine the I values and we combine the regular values. What do we do here now that we have an I squared? That's kind of a problem, isn't it? Well, take a minute, pause the video, and try to think to yourself, how can I represent this as a complex number? Remember, complex numbers need to be of the form a plus bi. Real number plus another real number times I. They don't have this component to it, this 9i squared. Pause the video and take a minute to think, what could you do with this 9 and the I squared? Well, hopefully you're thinking back to the fact that we know what I squared is. Remember, we defined I squared as equal to -1. They're the same value. So in this problem, we could say that we have 10 plus 21i plus 9 times -1. So if we went and simplified this some more, we would have 10 plus 21i minus 9. 10 and -9 makes 1 plus 21i. That is going to be our final answer, and it fits the form that we want of a complex number. So part of working with this when we multiply and we have this exponent on the I means that we have to understand that when I square I get -1. This is going to be very vital to how I go and simplify the expression when I do multiplication on it. And in fact, let's take a minute before we keep practicing this to take a look at what happens when I take the value I and I raise it to different powers. So let's first off take the value of I to the first. I to the first is just plain old I, right? That's the square root of -1. I squared, that's going to be, well, what is the square root of -1 squared? Well, that's just -1. What happens if I keep increasing the powers, though? What happens if I get I cubed? Well, let's see. That was I squared times I. So what did I have before? Well, I had -1, and now I have to multiply that by I. So I cubed is, in fact, -I. Now let's try I to the fourth. Well, that's just the previous term, I cubed times I. And I cubed was -I times I. So that's -I squared. And I squared is -1. So that's a +1. Take a minute, pause the video, try this out. I hope you're starting to see that there's this unique thing that's happening when I raise I to separate powers. When I have I to the first power, that's just the square root of -1, or just plain old I. When I square it, I get negative 1. When I cube it, I get negative I. And when I raise it to the 4th power, I get positive 1. What happens is I keep increasing these powers. Let's take I to the 5th power. Well, that's just I to the 4th times I to the 1st. So what was I to the 4th? That was a 1 times I. Hey, we just get I. I to the 5th power is the same thing as just I to the 1st. Let's increase it to the 6th power now. That's I to the 5th times I. Well, I to the 5th was just I, and if I multiply that by I again, I get I squared, which is negative 1. Looks like there's a pattern forming here. I to the 7th power. That's just I to the 6th times I. I to the 6th was negative 1 times I. That's just negative I. And then we have I to the 8th power. That was just the previous I to the 7th times I. I to the 7th was negative I. And if I multiply that by another I get negative I squared. I squared is negative 1, so negative 1 is positive 1. Take a look at that. We get the exact same values as before. What's happening with I is its values are cyclic. By that I mean they form a cycle. As you take I to the 1st power, you get I. I to the 2nd power is negative 1. I to the 3rd power is negative I to the 4th is 1. Then you repeat the cycle, and it starts back over at I, negative 1, negative I, and 1. As you keep going through the cycle of every 4 numbers, you keep repeating this particular pattern. So, if I gave to you I to the, oh gosh, let me think of one. Let's do I to the 66th power. What is that going to be? Now, you have to think to yourselves, okay, I is always repeating the pattern on every 4 intervals, right? Every 4th number, every multiple of 4, we end our cycle. And then the number after that is when we start back over, and we end it on the next 4th. So, pause the video, take a minute, and use this idea of how we are repeating cycles. Cycle 1, cycle 2. Think about how we're repeating cycles to determine what I to the 66th power is. All right, well, hopefully you had some time to figure this out. Now, let's think about this, again, in terms of the cycles. Every multiple of 4, we end the cycle. So what's the closest multiple of 4 to 66? Well, let's see. I'm thinking 64. So we have I to the 64 times I squared, right? That gets us I to the 66. Now, I to the 64, that's the end of a cycle. That's a multiple of 4. So that's the end to the cycle. So that was just a positive 1. Then I have the next term, and then the term after that. So, I squared is negative 1. Negative 1 times 1 is negative 1. You can almost think of it as this was I to the 64, this was I to the 65th, and this was I to the 66th power. Let's try that again, but this time with a different value. Let's try maybe even something a little smaller. Let's try I to the 27th power. Well, let's see. What is the closest multiple of 4 to 27? I'm thinking that's probably 24. I to the 24 power. So that's a multiple of 4, and then I have 3 left to get me to 27. So I to the 24, that's a fourth multiple, so that ends on a 1. So I to the 24 is positive 1, and then I'm multiplying that by I cubed. Well, I know that I cubed is just negative I. And again, I could also count the cycles of what's going on here. If I to the 24 is positive 1, then the 25th is just I, the 26th is negative 1, and the 27th would land me on negative I. Hopefully you're seeing this is the way that we can think about these patterns keep approaching again and again and again. We end every fourth value with positive 1, and then we start the cycle over. So you can just keep counting and see what value we'd end up with. Using this idea, let's try to solve a couple practice problems. First, we're going to start off with addition and subtraction. Pause the video, take a couple seconds to answer this, and then let's make sure you get the correct answers. All right, well, hopefully it's pretty obvious to you that when we go and add and subtract complex numbers, we're really just adding and subtracting the like components. So in the first case, when we have 4 minus 3i and 2 plus 6i, we're adding them together. We added the real components, and then we've added the complex components together. We did the same thing for subtraction, except in this case, we first went through and distributed the negative. Then we added the components together. Hopefully that part's making sense. And then let's try to perform multiplication with complex numbers. Again, I'm going to just use distribution with the box method. I have 2 and 5i, 3 and negative 8i. Pause the video, see if you're able to do this on your own, or if you like to do the regular distribution method, give that a try as well, and let's see if we come up with the same answer. All right, well, when we perform our distribution, whether it was the full horizontal distribution or the box method, we should end up with a 6, a 15i, and a negative 16i, which combine to negative 1i. And then we should end with a negative 40i squared. But keep in mind, this is not in the form of a complex number. It's not fully simplified. We have to remember that I squared is equal to negative 1. So instead of having I squared here, we should substitute in negative 1 for the value. So as we go and combine this, we get 6 minus I. Negative 40 and negative 1 is positive 40. So we should end up with 46 minus I as our final answer. Let's go ahead and try another problem. Again, pause the video and see if whatever technique you have is able to match up with our answers, and let's see if you're able to write your answer in the form of a complex number. Hopefully you're able to see that in your distribution you would end up with a negative 21, a 35i, a 12i, and a negative 20i squared. When you go and combine the like terms together, you get a 47i. And then, hopefully you went through and said, well, I squared is in fact negative 1. So by subbing that value in, you can combine it with the other like term to get a negative 1 plus 47i. This technique of where we go and perform our multiplication just like we did before is no different. This really shouldn't be that shocking of a technique to us. The only new thing we have to wrap our head around when it comes to this algebra is the fact that I squared is equal to negative 1. When we encounter higher and higher exponents of I, we need to figure out what could that value be equal to. This will happen in larger multiplication problems, but for right now, it's pretty straightforward, just simple distribution and box method. These are not that complicated. Hopefully, you're making sense to you. What's very interesting that we will cover in a later video is graphically what's going on when we perform these operations. When we do addition, subtraction, and multiplication on the real number system, we can see how the values change on the number line. But I wonder what happens when these values change in the complex plane. Until next time, feel free to contact me if you have any questions. My email is klinford@wccnet.edu. Let me know what you thought of the video or if you have any questions, and I'm happy to answer them there. Until next time, take care.